One-way analysis of variance can be thought of as a generalization of the pooled t-test. Instead of dealing with just two populations, as we do in the case of the pooled t-test, now we have three or more populations which we want to compare. We refer to these different populations as treatments. Here's an example. We may be interested in creating an underwater sensor array, and we want to test 4 different alloys for how resistant they are to corrosion. We take 5 3x5-inch plates and place each alloy plate underwater for 60 days. After this time, we count how many corrosion pits we can find on the 3x5 plate. Here we can see a listing of the alloy that was used and the number of corrosion pits on the plate. As you can see, on each alloy, 5 different plates were examined. To run a one-way analysis of variance in SPSS, begin by selecting Analyze, Compare Means, One-Way ANOVA. Now, move the numeric variable you wish to predict into the section marked Dependent List. In this case, pits is the numeric variable, the count of corrosion pits, so we'll move that to Dependent List. Now, the classifying variable which defines which populations are which gets moved into the window called Factor. If we want to get some further information, we can click on Options. If we'd like to see the means of each alloy, mean pits, we can click on Descriptive. And we can also perform a homogeneity of variance test. And we also have the option to have a plot of the different means. Once you select those, click Continue, and then OK to run the ANOVA. In the default output from One-Way ANOVA, we will see 2 charts. The first chart will contain information on the sample sizes for each treatment, and if you select descriptive statistics, it will also include the means and standard deviations of the items sampled within that treatment. The other chart which appears is the ANOVA table. In this ANOVA table, we will find some very important information. One thing we see is our mean squared error term. This serves as an estimate of sigma squared. Also, we will see a test to see if there's any difference between the means of the different populations. There are several F-tests in this output. The one we want to pay attention to in One-Way ANOVA is the one on the row with the variable which defines the population the item is from. In this case, that's alloy. Note that the F-test is testing the null hypothesis that all of the means are equal to one another. The alternative hypothesis is the opposite of that statement. That is, at least one of the means is different from others. The F-test for this hypothesis is gathered by the test statistic mean squared for treatments over mean squared error. And its degrees of freedom are determined by the degrees of freedom on the treatment for the first degree of freedom, and the second degree of freedom is from the degree of freedom for error. So this is being compared to an F with 3 and 16 degrees of freedom. Also note that the p-value for the test is listed on the far right-hand side of the table on the same row. In this case, the p-value is extremely small, so we'll reject the null hypothesis that all the alloys have the same mean corrosion rate, so it appears as if at least one of the alloys is different from the others. One last piece of information you can get from this table is the value of R squared. R squared represents the proportion of total variability explained by the model. It will be a number in between 0 and 1. In this case, 0.947 means that 94.7% of the variability is explained by the model that we set up here. To review, begin by selecting Analyze, Compare Means, One-Way ANOVA. Move the dependent variable over into the dependent list. Move the classifying variable into Factor. Click on Options to select any other additional output you'd like to have included. Finally, click Continue and OK